Okay, let's do an AP question of the day, non-calculator question dealing with continuity. So we're given this piecewise function. It's one of those x is not equal to and x is equal to, so you should be thinking there's a hole. It says, for what constant c is the graph of f continuous on the entire real number line? So take a second, pause the video, think about it, work it out, and then come back to the explanation. So when it wants to know for what value or what constant c is the graph continuous on the entire number line, it's wanting us to plug the hole. All right, so we got to figure out where it's supposed to be. That means there's going to be factoring involved. So we take out an x squared minus 3x plus 2, and then that'll go a little bit further. We can factor that into x minus 2 times x minus 1. Looky there, there's the problem. We remove the x minus 1, then we can plug in 1 because we're trying to find out, well, where would the y value be if it weren't a hole? So we plug it into the simplified version. 1 times 1 minus 2. 1 minus 2 is -1. So -1 is where our hole would be. So that is the value of c that would fix the problem, that would plug the hole so that it is continuous on the entire real number line. All right, let's look at a big theorem. I mean, it's not a huge theorem, but it will come up. You will see it somewhere on the exam, I promise. The intermediate value theorem. The intermediate value theorem in calculus. Let's look at what it says. Here's the theorem. If a function is continuous, this is why it's in the continuous section. If your function is continuous on a closed interval from a to b. So let me stop right there for just a second. Your function may have a discontinuity somewhere. So say, for example, you have a rational expression that has a vertical asymptote at 5. If your closed interval is from -3 to 1, that's okay. It's continuous on that interval. It just has discontinuity at 5. Well, 5's not in the interval, so it's okay. We can use the intermediate value theorem. Okay, so continuous on an interval. And k is any number between f of a and f of b, so in between the y values. Then there is at least one number, c, between the x values a and b, such that f of c equals k. So that's a whole lot of mathematical jargon right there. I've got a couple of examples here to illustrate what that's talking about. Okay, so we've got a continuous function. Let's just use the simplest example we can come up with for a continuous function. How about a line? So that's the first picture I've got there. I've got a line drawn. A is the beginning of my interval, b is the end of my interval, x value wise. Okay? So I've got their y values marked, f of a and f of b. What the intermediate value theorem is saying is there's an x value that has a y value between the y values of the endpoints. There's an x value that has a y value between the y values of the endpoints of your interval. There could be more than one. It says there's at least one number c. So that's the illustration that I have beside there. I've got a polynomial function, and I've got the interval marked off. I've got f of a and f of b labeled, the y values of the endpoints. And I've got a k. I just picked a random k in that interval, and I'm showing you that there are 3 x values that have that y value in that interval. Okay? So pretty much what this boils down to is that your continuous function cannot skip values. Okay? If you know at some point that your function's equal to 2, and then at another point it's equal to 5, then if that function's continuous, it's got to hit every y value between 2 and 5. One of those kind of duh things, but people tend to overlook it. Here's an illustration. A lot of times they like to use this to prove that a function has zeros. So you can see if k equals 0, the x-axis there, and I've got this function right here, from A to B, there is the C value right there where it has a 0. Because at A it was negative and at B it's positive, then between a negative and a positive number it's got to hit 0. Let's look at an example. This is what I was just talking about. We can use the intermediate value theorem to show that a function has zeros. Now, zeros, solutions, roots, x-intercepts, f of x equals 0, all those things mean the same, all those terms mean the same thing. So you've got to be familiar with all those terms and that they're leading you to the same conclusion. Example 1. Show that f of x equals x cubed plus 2x minus 1 has a 0 in the interval between 0 and 1. So they give us the interval. So let's start by plugging in our endpoints to find our y values. So plug in 0. 0 cubed plus 2 times 0 minus 1. 0 cubed is 0, 2 times 0 is 0, so f of 0 is negative 1. Let's plug in 1. 1 cubed plus 2 times 1 minus 1. 1 cubed is 1, 2 times 1 is 2, minus 1, so 1 plus 2 is 3, 3 minus 1 is 2. So at 0, we're equal to negative 1. At 1, we're equal to 2. So if we went from negative 1 to 2, we had to hit 0 in there somewhere, right? So here's what you need to write. If it asks you to show, this is how you need to write your explanation. So, f of x is everywhere continuous. And f of, hang on, I need more room to write this. F of 0 is less than, and by IVT, since f of 0 is less than or equal to 0, which is less than or equal to f of 1, there exists at least one C between x equals 0, or let's just say on the interval. That's better to say. There exists at least one C on the interval (0 to 1) for which f of c equals 0. Okay, that's how you need to write your answers if they're asking you to show that a function achieves a certain value. So since the function is everywhere continuous, by the IVT, since f of 0 is less than or equal to 0, the value in question, which is less than or equal to f of 1, there exists at least one C on the interval 0 to 1 for which f of c equals 0. Let's do another one. Use IVT to show that f of x equals x cubed plus x takes on the value of 9 for some x in the interval from 1 to 2. So plug in 1, we get 1 cubed plus 1. 1 cubed is 1, 1 plus 1 is 2. F of 2, 2 cubed plus 2, 2 cubed is 8, 8 plus 2 is 10. So, since f of x is everywhere continuous, by IVT, you can use IVT as an abbreviation on the final exam. They recognize that IVT represents the intermediate value theorem. Okay, you can use IVT. So by IVT, since f of 1 is less than or equal to 9, which is less than or equal to f of 2, there exists at least one C on the interval 1 to 2, for which f of C equals 9. Okay, because we started at 2, we ended up at 10, somewhere in between there we had to hit 9. Okay, so let's go a little bit further. We're given a function, and we've got to decide whether the intermediate value theorem holds, and if it does hold, we need to find where it occurs. And if it doesn't hold, we need to give the reason. So let's look at this one. F of x is equal to 2 plus x minus x squared. 2 plus x minus x squared. So it's a polynomial, it's continuous everywhere. So let's check our endpoints. F of 0. 2 plus 0 minus 0 squared is 2. F of 3, 2 plus 3 minus 3 squared. 2 plus 3 is 5. 5 minus 9 is negative 4. The value in question is 1. Is 1 between negative 4 and 2? It is. Okay, so the intermediate value theorem holds. So let's find our value here. We need to find out where this function equals 1. Well, it's a quadratic. So without a calculator, I'd probably like to try and factor it. So let's see if this is factorable. Now, because that's a negative x squared, I don't like that. I'm going to move it to the left side. So we've got positive x squared minus x, and 1 minus 2 is negative 1. Okay, bad news. It's not factorable. So if we can't use our calculator, our only option here, well, we've got two options. We can complete the square, or we can use the quadratic formula. I would rather use the quadratic formula. So x equals negative b. b was negative 1, so it's the opposite. That's 1 plus or minus the square root of b squared. Well, negative 1 squared is 1. Minus 4 times a, which is 1, times c, which is negative 1. All over 2 times a, which is 1. Okay, let's do a little simplifying. We've got 1 plus or minus the square root of, let's hear, 1 minus negative 4, so that's 1 plus 4, so that's 5 over 2. So that gives me two values, 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. Now, I'm trying to stay away from my calculator here. My interval's from 0 to 3. So just think about this for a second. Which one of these is in the interval? 1 plus the square root of 5 over 2 or 1 minus the square root of 5 over 2? I don't know exactly what the square root of 5 is, but I know it's a little bit bigger than 2. So if I subtract that from 1, I'm going to get a negative number. So my only option here is 1 plus 5, excuse me, 1 plus the square root of 5 over 2. That's got to be our C. And you could check it. You know, I'm okay if you want to check it with your calculator, but I want you to be able to do it without your calculator. And that number is definitely within our interval. Okay, let's look at another one. Let's look at a square root one. Okay, the square root of 25 minus x squared. So we got to make sure that this function is continuous on the interval that they're asking us about, because that's the first condition for IVT. So this has to be greater than or equal to 0. So let's see if it is. 25 minus x squared greater than or equal to 0. So that says 25 has to be greater than or equal to x squared. Or x squared has to be less than or equal to 25. So let's think about what values that would apply. Anything less than 5, right? So like 3 squared is less than 25. 4 squared is less than 25. 4.5 squared would be less than 25. So anything that's less than 5, and then let's think about negatives for a second. Negative 5 squared is positive 25. Negative 4 squared would be positive 16. So as long as we're between negative 5 and positive 5, we're good. We're continuous. We're defined. Okay, so let's check our interval. Does this interval fit in there? It does. Negative 4.5 to 3 fits within our interval. We're continuous. So next step is to check when we plug these in, f of negative 4.5. Now, you are going to have to use your calculator on this. Okay, they're not expecting you to square negative 4.5 by hand, which, I mean, it's not that hard, but they're not testing your algebra skills, even though sometimes it feels like they are. They say that they're not. I'm just telling you what they've told me. Okay? Yeah. Okay? But we just really need to know what that number is. Okay, and then we need to find out f of 3. So the square root of 25 minus 3 squared. So 3 squared is 9. 25 minus 9 is 16. So that's equal to 4. So our k equals 3. Is it between that decimal and 4? It is. So we're good. So then that means that we set our equation equal to that k, and we are going to solve for x. So we need to square to get rid of the square root. 9 is equal to 25 minus x squared. We got an option here. I'm just going to leave the x squared where it's at. So 9 minus 25 is negative 16. Get rid of the negative, and then take the square root. Plus or minus 4. You've got to be in the habit of the plus or minus. You have to be in the habit of plus or minus because look at our interval. If you just did positive 4 is not in your interval. Negative 4 is the C that is in the interval. So you got to be careful. Get in the habit. They will get you with that. I promise they will get you with that. I've seen several questions where they try and make sure, are the students remembering to check the negative side of things? Okay, let's do one more. Let's look at a rational function, 1 over x minus 2. This is kind of what I was telling you before. Where's our vertical asymptote? It's at positive 2. Is positive 2 in our interval? No, it is not. The discontinuity is outside the interval, so on the interval from 3 to 5, we're continuous. So we can apply the intermediate value theorem. As long as when we plug in 3 and 5, we get the conditions that we need. So plug in 3, 1 over 3 minus 2. 3 minus 2 is 1, so that's 1. F of 5, 1 over 5 minus 2. 5 minus 2 is 3, so that's 1/3. 5, 6. Ooh, is 5, 6 between 1/3 and 1? Hopefully you know that it is, but you may need to put this in terms of sixths, so you know. And yes, 5/6 is between 2/6 and 6/6. So let's find out, this is fun, setting this equal to 5/6. Now it's really not that bad. Okay, when you got a fraction equal to a fraction, cross multiply. 5 times x minus 2 equals 6 times 1, which is 6. So we've got 5x minus 10 is equal to 6. 5x is equal to 16. So x is equal to 16 over 5, which does fall within our interval. Okay, 16 over 5, 16 divided by 5, 5 goes into 16 5 times with 1 left over. Excuse me, 3 times with 1 left over. So 3 and 1/5, that's between 3 and 5. So C is 16 over 5. They like improper fractions on the final exam, on the AP exam, and I do too. Okay, so try out these problems in your textbook with the intermediate value theorem.